Hello everyone, myself Sakshi Mittal, and today I am going to discuss about the unit 1, a complex topic, that is the types of satellite. The subject is satellite communication and we are going to, the subject code is KEC 062. So first, before going to the types of satellite, we must know what is a satellite. As we know, if there are two bodies, a larger or smaller body revolving around a smaller body, we call it as a satellite. As we can see in the first slide, that it is the interplay of sun, earth and moon. So as from the diagram, we can see that the sun is also revolving on its own orbit. It completes its orbit in 27 days. We have the earth we call it as a, it is orbiting around the sun, and it is also orbiting on its own orbit. It is also revolving on its own orbit. It completes its orbit in 24 hours. We call it as a 1 day. We have a moon is orbiting around the earth. It is a satellite of earth and it completes its rotation, its one orbit rotation in 28 days. So we can say that any smaller body which is revolving around a larger body is a satellite. So we can say that a satellite is a celestial body that orbits around a planet. For example, moon is a satellite of earth. Or in aerospace terms, a satellite is a space vehicle launched by humans and orbits around earth or any other celestial body. We can say that for what purpose we are going to have a satellite. We can have a communication satellite. So the types of satellite, they can vary as per the application of that satellite. So we can have a communication satellite. So communication satellite, it is nothing but a microwave repeater in the sky that consists of a diverse combination of one or more components. So the components can include a transmitter, we can have a receiver, amplifier, regenerator, filter onboard computer, multiplexer, demultiplexer, antenna, waveguide, etc. A satellite radio repeater is also called as a transponder. This is actually a combination of transmitter and receiver. Now, what is satellite? So, as from this diagram, we can see that the Sputnik 1, which was launched in 1957, it was actually the first satellite that was launched. And we can see here the components. In the above picture, we can see the components for the satellite. We can see that we have, what are all the components of the satellite. We can have an antenna, we can have some batteries, we can have a shield, we can have a transmitter, a fan diffuser, a remote switch. So, these are all the components of the satellite. So, the India's first satellite, it was Aryabhatta. It was the 360 kg satellites. Now, see, first we can differentiate the satellite as per the application, as we call it as a communication satellite. Now, the second classification can be as per the weight, as in the case of the Aryabhatta, I am saying that it is a 360 kg satellite that was built by ISRO to gain experience in orbiting a satellite in space. It was launched in April 1975. So, the aim was to conduct an experiment in X-ray astronomy, aeronautics, and you can say the solar physics. It re-entered the Earth's atmosphere on February 11, 1992. So, satellite is nothing but any object that revolves around a given planet in a fixed orbit under the influence of planet's gravitational force is called as a satellite. Now, we can say that satellite, there can be two types of satellite, natural and artificial satellite. So, if it exists in nature, if it is already existing in nature, we can say it is a natural satellite. For example, I said that moon, it is a satellite of earth. So, it is already existing in nature, we can say it is a natural satellite. Second one is the artificial satellite. So, artificial satellite, we can say that all the man-made satellites or the satellites that are made by the scientists or the human-made objects, which we have made it to revolve around a given planet in a fixed orbit, we call it as a artificial satellite. Now, if we have placed a satellite, how will it communicate? So, the communication, it takes place, it exchanges the information between any two earth stations. It will exchange the information, like I have got a earth station here, it is my earth station, and then the signal will be transmitted in the upward direction to the satellite. Then the satellite will further shift, it will redirect the signal, it will send the signal downward to the second satellite system. Now, we say the Earth Station 1, which is transmitting the information upwards to the satellite, we say this is the uplink. we have transmitting information to the upward side, so it is the uplink signal, and the satellite which is transmitting information downward, this is the downlink signal. Now, the satellite which is already existing, so it is not necessary that the two satellite, the two earth stations which are communicating with each other, they are in the one region, it is not necessary. So, the space segment that the satellite, it needs to have some information, it needs to have some control. So, this TTNC, this telemetry tracking and control block, so it exchanges the information from this. So, the communication takes place between any two earth stations through a satellite, as I have mentioned in the space segment. The EM waves, the electromagnetic waves, they are used as the carrier signals. It can carry the information such as voice, audio, video, or any other data between the ground and space, and vice versa. So, the two stations on earth want to communicate through a radio broadcast, but they are too far to use the conventional means. If they are located nearby, then I can have the ground waves, I can communicate via the fixed lines. But if they are too far that I cannot communicate using this conventional means, then I have to communicate via satellite. The two stations, they can use a satellite as a relay for their communication, or we can say it is a medium. So, one earth station, it transmits the signal to the satellite at some frequency. We call it as the uplink frequency. So, the frequency at which earth station is communicating with the satellite, that is called as the uplink frequency. And the second, the satellite transponder, it processes the signal with the help of TTNC block, and it sends it to the second earth station at another frequency called as the downlink frequency. So, now is the need of satellite communication. Why do we need to have a satellite? We can have a ground, we have different layers. As we go upwards in the atmosphere, we have different layers of atmosphere, which plays a role, we will have a very important role in propagating these radio waves. We have at certain height around 18 km above the earth, 18 km, we have troposphere, then we have stratosphere, ionosphere, exosphere. So, these layers, as the attenuation increases as we go upwards. So, these layers, they play a very important role. So, we can have two kinds of propagation, a ground wave propagation and a sky wave propagation. So, ground wave is suitable for frequencies up to 30 megahertz, but if we want to go beyond it, then we call it as a sky wave propagation, or for the long distance we use the, we can say the space wave, or we can say the satellite communication. Or we can say when we have something to communicate beyond the line of sight, then we use this satellite communication. So, as mentioned in the picture, we can have a ground earth station which sends the signals at some frequency called as the uplink frequency to the satellite. Then this satellite will transmit the signal back to the destination ground station at a certain frequency called as downlink. Now, these two frequencies, they are not same. So, my uplink and downlink, they are transmitted at different frequencies, so that they do not interference. So, to avoid the interference, we are transmitting at different frequencies. Generally, we transmit the signals in C band. For satellite communication, we generally use C, Ku and Ka band. So, if we use C, then we say that uplink is at 6 gigahertz and downlink is at 4 gigahertz. So, now we can see that the uplink is at higher frequency than the downlink. So, what is the reason behind this? When I am transmitting it at a higher frequency, we know that as the frequency increases, the attenuation also increases, and you need high power to transmit the higher frequency. So, when I am at the earth station here, while transmitting, I can afford to have a high power transmitter to send the signal at high frequency. When transmitting downwards at the satellite, I cannot afford to have high power, I have a limited power, because we are using the solar panels, we are using the power from the solar panels. So, we cannot afford to have high power. So, we have a limited power. So, that is why the frequency, this frequency is generally lesser than the downlink frequency. So, these are the bands that we can use, the C, Ku and Ka band. So, approximately 4 gigahertz downlink and 6 gigahertz uplink for the C band. It is the actually most frequently used band, and the Ka and Ku band are also used for satellite communication, but they are subject to rain attenuation. Now, coming to the types. So, we have seen that we can have types as per their material. As if we are saying that if they are already existing in the nature, we call it as a natural satellite, and if you have made it, if these are the man-made or the scientists have launched the satellite, they are artificial satellites. So the planets, these are our natural satellites, and you can see some of the pictures which shows that we have some other artificial satellites. Then as per their uses, so we can have active or passive satellite. We say we have a satellite. Active satellite is actually used for linking and also for processing the signal. I've sent a signal upwards. It is the satellite has captured that signal. It has linked your two earth stations on the ground, and it is also processing that signal. You have the satellite has received the signal. It will again regenerate that signal. It will amplify the signal, and then it will again forward the signal downwards. So we can say that active satellite, they are used for linking and processing both. They are doing both the tasks, and that linkage, it is known as the bent pipe technology, where your processing like frequency translation, your power amplification, they take place. So active satellite, they employ regenerative technology, which consists of demodulation, processing, frequency translation, switching, power amplification. All these processes are carried out, and the block used for this are the transponder. On the other hand, these are passive satellites. The passive satellites, they do not use the onboard processing, and they are just used to link two stations through space. So if I have got an earth station here, I want to communicate between these two earth stations, and I am sending a signal to a satellite. So I can say that this satellite is just used as a medium for linkage between these two earth stations, then that is a passive satellite. So it is not doing any kind of onboard processing. It is just used as a linkage between these two stations. So the passive satellite, they are my low cost, low power is associated with them, and as the passive satellite, they are not doing any kind of processing. I am not doing any kind of frequency translation or the demodulation, processing, power amplification, nothing is being done by the passive satellites. So I cannot use them for the communication purpose. Now the next is how we can classify satellites according to mass. So we can classify satellites according to their weight. What is the weight of satellite? Like when we have, in case of Aryabhatta, we have seen that it is around 300 kg satellite. So we can classify satellites according to their size. If they are very huge satellites, we can say that they are the very large satellites. Then if the weight is slightly less, we can say that these are the medium sized satellites, and if they are lightweight satellites, then we can call them as small satellites. So if you have the satellites which weighs more than 1000 kg, they come under the category of large satellites. If you have a weight around 500 to 1000 kg, then it is your medium sized satellites. Then small satellites, they are further categorized into mini satellites, micro satellites, nano satellites and pico satellites. So you can see in case of mini satellites, I have 100 to 500 kg. So if the satellite weighs around 500 to 500 kg, we have mini satellites. If it is 10 to 100 kg, we call it as a micro satellites. For nano satellites, that is 1 to 10 kg, if the weight lies in this range, that is 1 to 10 kg, we call it as a nano satellite. Pico satellite, when my weight is less than 1 kg. So we call it is so small satellite that my weight is even less than 1 kg. As from this picture also we can see, so my satellites from less than 1 kg, these are my pico satellites. If I have 1 to 10 kg weight, then these are my nano satellites. They are slightly larger than these pico satellites. Then if you have 10 to 100 kgs, you have micro satellites, and you can have 100 to 1000 kg, where you can call it as a small or medium sized satellite. So if they are lies in the range from 100 to 500, then they are still in the category of small satellites. But if you go beyond 500 kgs but less than 1000 kg, so they are your medium sized satellites. So first we have classified them according to their existence. If they are naturally existing in the nature, we call it as a natural satellite. Then we have classified it according to their weight, according to their mass. So we have classified it into large, medium and small satellites, and small satellites further classified into mini, micro, nano and pico satellite. So now for what purpose can we use as the weight increase? If I say that I have a large satellite, if I have a large satellite, obviously then I have mounted a large number of components on it. So and if I say that I have reduced the weight, if I have reduced it and if it is less than 500 kg, so we say it is a very small satellite. If it is a small satellite, then for what purpose you can use it? Because now you are limited. You don't want to increase the weight, so you cannot increase the components mounted over that. So you have to be limited. So I can say that these small satellites, also I can call them as a nano satellites. They are the new age satellites and they are prepared for specific purpose. As I am limited for my components, I cannot have all the components mounted on the satellite, otherwise it will increase the weight. If it will increase the weight, then it will the size will also increase. So I have to design it for some specific purpose. So the weight of small satellite, it is less than 100 kg and it has smaller electronic components, so that I can have a weight less than 100 kg. It is working towards cost effective future space missions. So we can place the small, like we used to see we have some drones. So that drones are also, they are very small. So we are looking towards the cost effective future space missions. Over the last 50 years, around 860 microsatellites. Microsatellite means where the weight is lying between 10 to 100 kg. So they have been placed, and 680 nanosatellites. Nanosatellites around weight is less than 10 kg. And 38 picosatellite, where my satellite weight is less than 1 kg, that is 0.1 to 1 kg. They have been launched worldwide. So the small satellites, they are being used to record data on the terrestrial and space environment near moon and the earth, and they demonstrated various telecommunication systems. The various small satellite that can be used, various small satellite we have which have been launched are, there's some examples are Jugnu, SRM sat, then we have YouthSat, StudSat, and all these are the HAMSat, NUSat. These are all the examples of small satellites which have been launched for some particular application. The weight is less than, we have got a small size, the weight is less, and we have just launched it for some particular application. If we talk about one of the example, that the StudSat, it is an Indian small satellite which weighs just 1 kg and it has a camera which can take pictures of Earth from space, and it helps in weather prediction. If it has a camera on board on it, so with the help of camera I can take pictures. For what purpose I can use those pictures? If I am taking a picture of a land, then I can use it, for example, for monitoring or for weather prediction. I want to check the weather, or for remote sensing. If I want to capture pictures, I can take it for surveillance, I can take it for remote sensing. I want to check the amount of greenery on that particular land. So StudSat is one of the Indian small satellite which have been launched just to take pictures of Earth from space. It is around 1 kg. So for small space exploration, these small satellites, it provide an efficient and economical means to identify the regions of interest before sending large space system with more instrumentation. So it says that if you have certain kind of interest, if you want to explore that part of land, if I am saying that I want to launch a satellite for remote sensing purpose, I can first send a small economical satellite just to identify the regions of interest where I can fulfill that my application. So before placing a huge large satellite into the space with large instrumentation involved, I can just place a small satellite which weighs around just 1 kg. Another example is in 2010, a student of IIT Kanpur, he developed the first nano satellite of India and named it Jugnu, which is later launched in October 2011 by ISRO with PSLV-18 from Sriharikota. This Jugnu, it was 1 foot long, 10 centimeter wide, and it weighs less than 3 kg. This satellite, it was also launched equipped with a near infrared camera, and it transmits images to the base station at IIT Kanpur campus. So we have seen that the satellite, this small satellite, they are just for the particular application. If you can see, you are using these satellites for testing purpose, or just for the prediction, for weather prediction, for remote sensing purpose. So you can have, if you have a particular land area and you want to just click the pictures, you can use these small satellites. Next, I can classify the types. Firstly, we have classified according to the existence, then we have classified according to their mass. Next, I can classify them according to their orbits in which they are placed. So, now first, how can I classify the Earth orbit? So, my Earth orbit can be classified as per the inclination. So, if you have, just see in the first diagram shows the equatorial orbit. If a satellite, it is revolving around the Earth, are parallel to the equator, we call this as the equatorial orbit. And if I have if a satellite is revolving around the Earth, covering over the poles, we call it as a polar orbit. And the third one is the inclined orbit, when the orbit, it is just tilted, it has some inclination. So, if I place some satellite in this orbit, then I can again classify them. So, equatorial orbit, it is an orbit around the Earth that lies in the plane of equator. So, satellite moves in a circular path which is parallel to the equator. So, it is commonly used for your communication and broadcasting application because it provides continuous coverage to the fixed area. So, it is rotating around parallel to the equator, it provides continuous coverage. Next one is the polar orbit. So, a polar orbit around the Earth, it passes over the poles. Satellite in a polar orbit, it moves in a circular path that passes from north or to the south poles. This is commonly used for your remote sensing and imaging applications, and it also provides complete coverage of Earth's surface. See, in case of equatorial orbit, I am having the continuous coverage, and in case of polar orbit, I am having the complete coverage. So, the choice of orbit for a satellite, it depends on the specific requirement of that application. The equatorial orbit, they are preferred for applications that require continuous coverage for a fixed region. So, if I require if I want that I should have a continuous coverage, but I am limited to a specific region, then I will refer the equatorial orbit. And if I say that I have some application where I require the complete coverage, I have a wider area, then we need the polar orbit. Then the inclined orbit, they can be used for some applications that require coverage of a large area of Earth's surface, but they do not require continuous coverage of that fixed region. So, if you want to just have a picture from a particular area above it, so that means that you want to have a continuous coverage of that area of a fixed region. So, you need equatorial, but in case of inclined, I am saying that I do not need continuous coverage of a same single region, where I require the complete coverage of a large region. So, we can use the inclined orbit. Next, I can define it, we can classify it as per the shape. So, if the path or the orbit at which my satellite is rotating, if that is circular in shape, we can say it a circular orbit, and if the orbit through which it is going, if it is like an ellipse shape, it is elliptical orbit. So, by shape we have classified into circular and elliptical orbit. A circular orbit is an orbit in which the satellite moves in a circular path around the Earth at a constant distance from the Earth's center. So, the shape of orbit is a perfect circle and the speed remains constant throughout the orbit, and it will be ideal for applications that require a stable and predictable orbit, such as my communication and navigation. While your elliptical orbit, it is an orbit in which the satellite moves in an elliptical path around the Earth. So, the shape is an oval or the elliptical shape, and the speed will also vary. In case of circular orbit, we are at a constant distance from the center of the Earth, but in case of elliptical, somewhere you are closer to the Earth, somewhere you are at distance far away from the Earth. So, we say that the speed of satellite, it varies throughout the orbit. If the satellite moves, the satellite will move faster when it is closer to the Earth and will move slower when it is farther away. For example, if this is the center of Earth and I have this ellipse, if my satellite is, let's say, rotating is at this position, it is farther from the Earth, so it will move slowly, so that it is at it is in view for a long period of time. But as soon as the satellite will come to this position, let's say this area it will cover at a high speed. So, this will cover this area very fast. So, we can say that if we are far from the Earth center, then it will move slowly, but if it is behind the Earth, it is very close to the Earth, it will move very faster. So, we can use this elliptical orbit for the applications that require wide coverage area, such as your remote sensing or Earth observation. Next is the satellite types according to the placement in orbit. Now, at what altitude you are going to place the orbit. So, based on that also we can classify the satellites. So, we can have, so first we have the Earth, then we have the different altitudes, like we have a 1000 kilometer, then at 10,000 kilometer, then at 36,000 kilometer. At 36,000 kilometer we have the we have geo Earth orbits, we have geostationary Earth orbit. So, first one is the low Earth orbit. These orbits, they are differentiated based on their altitudes. If I say about 2000 kilometer, I have a low Earth orbit. If I go beyond it, we have medium Earth orbit. Then we have geostationary, or we can say geosynchronous orbit. At these orbits, the satellite will move at different speed. So, the speed is varying. If the satellite speed is varying, the time for the duration for which my satellite is visible, that visibility period is also varying. So, we can say that in case of low Earth orbit, we have orbital period of around 90 minutes. For medium Earth orbit, it varies from 2 to 12 hours. Then for geostationary or geosynchronous, the satellite is visible for 24 hours. So, we can use these global star is the example for low Earth orbit satellite. Then GPS can be example for medium Earth orbit satellites. Then for geostationary or geosynchronous, we can have broadcasting or communication satellites. So, low Earth orbit satellite, they have an altitude between 160 to 2000 kilometer. They take approximately 90 minutes for one revolution, and the majority of artificial satellites are in low Earth orbit. So, the Earth observation or the spy satellites, they are generally the in this category. So, these signals, they have a better signal strength, we have a shorter propagation delay, and they are better for point-to-point communication. But the only disadvantage is that we are limited to the specific area. We have a small coverage. Then medium Earth orbit satellites. So, we can also call them as intermediate circular orbit, and they have a better navigation. We can use them for navigation, communication. They have orbital period of 12 hours as used by GPS. They have a larger coverage area as compared to the low Earth orbit satellite. And as they have a larger coverage area, so we require less number of satellites to provide the complete coverage. But as the distance is higher, so they take long time to travel, and with the signal quality also degrades. Then the geosynchronous orbit, it is around 36,000 kilometer above the Earth's surface. So, as we are traveling so high, so signal quality will degrade, but the coverage will increase. So, around 3 satellites can provide the complete coverage. Now, geostationary and geosynchronous, they are around at 36,000 kilometer. The only difference is in case of geostationary satellite, geostationary orbit, it is orbiting at the same speed as the Earth rotates, but it orbits around the equator. While in case of geosynchronous orbit, it is inclined. It is orbiting over the poles. So, we have the large coverage area, that is the biggest advantage. We have 24-hour visibility of a particular area. It is ideal for satellite broadcast and multi-point applications. The only disadvantage that we have a large propagation delay. It makes the signal quality degrade. High Earth orbit satellites, they are not widely used. It is a geocentric orbit with an altitude entirely above that of geosynchronous orbit. So, we can classify them as per the satellite height, then the orbital period, and the number of satellites. As in case of low Earth orbit satellite, we are restricted to very small coverage. So, I need more number of satellites. Let us say 40 to 80 satellites I have to place in one orbit, so to have a complete coverage area. Then in case of medium Earth orbit, we need around 20 satellites to provide the complete coverage. Well, in case of a geostationary orbit, I need only 3 satellites to provide the complete coverage. Propagation loss is also, it is less in low Earth orbit, but it increases as we go higher. So, the satellite types, it can be geostationary and synchronous, as I already mentioned in the previous slide. So, if it is rotating around the Earth at the same speed, it is actually assumed, if a person is on the Earth, we see it as it is a stationary, the satellite is stationary, it is actually rotating, but at the speed of Earth. However, in case of geosynchronous, it has some angle of inclination, it is tilted, so it is covering over the poles. So geostationary, it is an orbit in which satellite revolves around the earth at the same speed. In case of geosynchronous, it is inclined towards the earth equator. Now the only problem is if I have a satellite which is near the equator and it has to provide coverage over the poles. So in case of geostationary, it is difficult to provide coverage over the poles. So geostationary and geosynchronous, they differ in position. The geostationary satellite, it appears to be in fixed position relative to an observer, while geosynchronous, it oscillates, it covers from poles, like from north to south pole and then to the other. So it follows a figure 8 pattern. Then altitude is approximately 36,000 kilometer and it is 35,786 kilometer. Geostationary are in the equatorial plane, while my geosynchronous, they are in equatorial plane. Inclination to the equatorial plane. That is my polar satellite. So lastly, we can classify them as per their application. We can have a communication satellite, which we are used for communication. We can use it for voice, video, data. Then we can have the remote sensing satellites. So remote sensing satellites, you can use for particular any surveillance. You can have a navigation satellite if you want to, if you have some unknown object you want to locate it, then you can have the satellites, or we can have it according to the orbit type, low Earth orbit, medium Earth orbit, then high Earth orbit satellites. We can have we can vary them according to their size, the nanosets, CubeSats, small sets. So all these types of satellite, they can be varied according to their applications. Further, we can say the satellite services. So as we said that satellite, we can have a one-way link or we can have a two-way link. First Earth station and between the second Earth station. If you have, it again depends on the application, as we have mentioned in the previous slide. If you have an application of broadcast, then you want it to just from the satellite want to transmit it, but on the Earth station, the receiving Earth station doesn't want to send it anything backwards. So it depends on the link. So you can have a one-way link or you can have a two-way link. So we have seen that all these types of satellite services, they are basically dependent on the application. So one-way satellite link or the two-way communication, you have a broadcast satellite like a radio, TV, internet services, or you can have the fixed services. So we have again, we have classified them into fixed satellite service, broadcasting. Fixed means that you are limited to a particular telephony region, and broadcasting, you are broadcasting it to broadcasting like to a direct to the home. Then you can have the mobile satellite service, radio navigation satellite service and radio determination satellite service. One service which is primarily important to the operation of satellite service is inter-satellite service. If the satellites, they are not in the same, if the two Earth station which wants to communicate with the one another, they are not in the same space, or we can say over the same region, then they have to need to communicate, exchange the information. So we can have the inter-satellite links between them. So inter-satellite service, they plays a important role, like I have explained the previous diagram, that we have got a TT and C block, this telemetry tracking and control block. It actually communicates, it helps to communicate between the satellites. It gives information which is my first Earth station which wants to communicate and which was the second Earth station. So in this lecture, we have covered about the types of satellite based on their existence, then as per their weight, that is as per their size. Then we have classified them as per their orbit in which they are placed. Finally, we have discussed how we can classify satellites based on their applications. And the book which I have used for this is, I have used the Pratt and the John Roddy. Thank you.